Hi students, this is Mr. Yao. Today we are going to talk about 2.1b, where we will use the algebraic properties that we have learned in the last lesson to justify solving equations. But first, let's talk about that word, justify. Justify a lot of times just means you're trying to prove something, you're trying to explain something, or you're just trying to find a reason to be able to kind of prove, to show, oh, this is right. So that was justify is, and that's exactly what we're going to do with a lot of these property questions. So it is about thinking logically and solving problems step by step. Of course, now we're going to go very tiny steps. So that's why we need to understand why they're happening. The key idea is you have to think what changed from one line to the next line. These changes, these very obvious changes, will be able to help you to identify what kind of property is being used or properties are being used from step to step. So let's have a look at the first example. There we go, example 1. First thing, we're going to look at what changed from the original question to step A. You might have noticed the 7/4 didn't change, the +5 didn't change, the 1/4 n didn't change, the -9 didn't change. However, you do have a 4 and another 4 on both sides. Some of you might be saying, oh, like we also have extra parentheses. Well, the parentheses are being forced to be there because you have the 4 that are multiplied. So when that happens, that means you're multiplying both sides by a same number, and that is the multiplication POE, or multiplication property of equality. Okay, next, from step A to step B. You might have noticed, oh wait, now everything has a 4. And we have more parentheses. Yes, these are all correct, but more importantly, you might have noticed the 7/4n and the 5 used to be in the same parentheses. Now they split up. The 1/4n and the -9, they also split up. And of course, because they split up, everything is getting a 4 individually or separately. And in that case, it is distributive property of multiplication. You're trying to distribute right now to get rid of the outside layer of the parentheses. The only reason I'm putting them inside parentheses is just because, well, we're trying to make things a bit clearer to actually kind of see how they're being multiplied with the 4. Next, from step B to step C, let's pay attention to what changed. First, you might have noticed the fractions are gone. There's no fraction. So this 4 and this 4 together, well, not only are the fractions gone, you also got a 1 there. Same thing on the right side, the 4 and the 4 on the bottom of the fraction, they become a 1. That's one type of change. Then the other, the 4 times 5, changed into a 20. The -4 times 9 changed into a 36. So let's think about it. 4 times 1/4, so it's 4 times 1/4 here, or it's also 4 times 1/4 here. That gives you a 1. When you multiply both things and you get a 1, that means they canceled out. And that property is called an inverse. However, the 20 and the -36, they don't have 1s. But 4 times 5 is 20, -4 times 9 is -36. So you're actually replacing the 4 times 5 by something that it equals to. You're replacing the -4 times 9 by something that equals to, which is -36. So there are actually two things happening. So there we go. Multiplicative inverse and substitution properties. So this one is a bit special. It has two different properties. Now again, 4 times 1/4, when you try to get rid of the fractions, you got a 1. That's where the inverse happened. And then you're just replacing a kind of multiplication by whatever the answer is. You're replacing them by something that equals to. That is substitution. And one extra thing, about 95% of the time, inverse and substitution, they go hand in hand. They come together. Because when you have multiplicative inverse, that means you're trying to multiply. And then, of course, when you don't get a 1, but you still did your multiplication, that's going to be called substitution. Moving on, next step. From step C to step D, you might have noticed the 1 disappeared. The 1 disappeared. In that case, it is multiplicative identity. When you multiply with a 1, you get the same thing. That's an identity when that thing doesn't change. So there we go. D is multiplicative identity. So for now, you might have seen it's like all separate properties, but from now on, you might start recognizing some patterns. So let's keep going. B, again, we just talked about it. That is multiplicative identity. Moving on, step E, you can see the left side, there's a negative n. On the right side, there's also a negative n. Whenever you're doing the same thing to both sides of the equation, it's going to be a POE, property of equality. And since the operation is subtraction, in that case, it has to be subtraction, POE. Next, step F. Well, step E is not entirely a step, so you're not looking for what changed from step E to step F. You're actually looking for what changed from step D to step F. So now, you see n change into a 0. Well, there's a reason, because n and a negative n together, it change into a 0. And then 7 and a negative n together, it change into a 6n. N and negative n, so positive n together with a negative n, they're opposites, they add together and get a 0. That is the additive inverse. Just like I was saying in the previous step in step C, whenever you have inverse, you will have substitution, because on the left side, 7n minus n, well, that is 6n. That equals to 6n. So you kind of did the calculation, and that is substitution. So there you go. Step F is additive inverse and substitution property. They always come hand in hand, additive inverse and substitution. Moving on, you see the left side did not change, 6n is still there, 20 is still there, but the 0, well, that disappears. The 0 disappears. In that case, when you add a thing to a 0, you got the same thing back. That is additive identity. Whenever you're not exactly changing things, you're just getting rid of a 1 or a 0, that's going to be the identity. Step H, well, step H is very similar to step E if you look at it. Step H and step E, they're about the same. They're both subtracting things on both sides of the equation. So that is subtraction, POE. Afterwards, we have the 20 and the negative 20 together become a 0. And then the negative 36 and negative 20 becomes a negative 56. So first, the 20 and the negative 20, they're opposites. They add together and get a 0. That is going to be inverse. And the right side, negative 36 and negative 20 together, it is negative 56. So there you go. Additive inverse and substitution property. Additive inverse and substitution property. For by now, you might have noticed, whenever you're trying to get a 0, which is the inverse, that is going to be the, well, whenever you're trying to get a 0, that's going to be the inverse. Whenever you're getting rid of a 0, that is going to be the identity. So next step. Now you see the 0 is gone, 0 disappeared. That is going to be additive identity. Additive identity. Next, step K. When you're dividing the same thing on both sides of the equation, there you go, division POE. Again, whenever you do something to the left side and something to the right side, that is going to be the property of equality, so POE. Since the operation is division, so it's called division POE. Next, one thing you gotta clear your mind, you gotta understand, be able to wrap your head around is, subtraction is addition. Let me write it on the top. Subtraction is addition. Minus 5 is the same as a plus a negative 5. That's the same thing. And division is multiplication. Because whenever you're trying to say divide by 6 in this case, it's the same as multiply by a 1/6. That's why we don't have the subtractive inverse or divisive inverse. We just have additive and then multiplicative. So technically, this step, even though it's division, divide by 6, is actually the same as multiply by 1/6. So you are actually doing a 6 times a 1/6 that gets you a 1. So of course, whenever you multiply and get a 1, that is going to be the multiplicative inverse. Right side is negative 56 times 1/6, which is negative 56 over 6. So that is just replacing by something that is the same. So there you go. Multiplicative inverse and substitution property. Then from step L to step M, you can see the 1 disappeared. The 1 disappeared. And in back, the right side stayed the same. So when you multiply something with a 1, you get the same thing back. That is going to be multiplicative identity. Lastly, the right side, it used to be negative 56 over 6 and changed into a negative 28 over 3. Well, that's just simplifying fractions. So in other words, you're replacing something by something else that it equals to. So substitution property. By now, you might have felt like, oh my god, this example has so many steps. But maybe you have recognized some patterns already. So now let me point out some patterns for you if you still haven't recognized them. Let's go back to the first slide, part. Let me point them out. You have a POE, then it's followed by an inverse. Together, it's always going to come with a substitution with the inverse. So you have POE, then inverse, substitution, and then identity. That is called a three-step chunk. Three-step chunk, which is POE. Of course, it has to be specifically with the operation. And then it's inverse and substitution. And lastly, identity. That is the three-step chunk. Now let's check if that actually works. So besides right here, besides these three steps, you only have a step B, that is the extra distributive property of multiplication. Okay, moving on. Let's check the next part. You have a POE, followed by inverse, and substitution, then identity again. There you go. Three-step chunk. EFG is a three-step chunk. Then we have POE, inverse, substitution, inverse and substitution, and then, of course, the identity. So you have a three-step chunk again. Moving to the next part, POE, inverse, substitution, and identity. There you go. That's another three-step chunk. So see, the whole question is just by these three-step chunks. Besides those, you only had a distributive property of multiplication, that step, and a substitution step, that is kind of extra. But everything else, they are just the three-step chunks. So even though it seems like long, they're quite repetitive, and that's a quick pattern for you to kind of notice. That is example 1. Now let's move on to example 2. This time you're not given all the solving steps, so let's have a look. First, you see the right side says distributive property of multiplication. On your notes, I did actually make a mistake. I said equality is supposed to be distributive property of multiplication. Now, in order to do that distribution, you basically get rid of the parentheses. That's what distribution does. So 9x minus 18 minus 2 equals 7. There you go. I got rid of the parentheses. I multiply them through. 9 times x is 9x. 9 times -2 is -18. So there you go, distributive property of multiplication. And then again, you gotta pay attention to what is changing from a step to the next. And in this case, from step A to step B, here's what's changing. The -18 and the -2 become a -20. The 9x stayed, the 7 stayed. So you're replacing something with something else that it equals to, because -18 minus 2 is -20, so substitution property. Step C, it says addition POE. POE means you're adding something on both sides of the equation, and it's addition, so you need to add something on both sides of the equation to keep solving. You kind of see the next step, you got a 0, so you are going to have to add both sides by a 20. Next, from step C, well, actually, technically from step B to step D, -20 and +20 together become a 0. 7 and 20 become a 27. So the opposites add together get a 0, that's inverse. The 7 plus 20, it is 27, so you're just replacing, there you go, additive inverse and substitution property. That's step D. Next, the property said additive identity. Whenever you have an identity, that means you're just adding 0 or multiply by 1, and you're not changing that thing. So it's going to be 9x equals 27. Step F, left side is being divided by 9, right side is also being divided by 9. So there you go, division POE. You're just dividing the same thing on both sides of the equation. Step G, the 9x is being divided by 9, and the 27 is also being divided by 9. That's something you got to jump, well, if you look at it, h is already x equals 3. Well, so there's no way g is also x equals 3. Then you're not doing anything from step G to step H. But whenever you are dividing, again, it's the same as multiplying by 1/9. 9 times 1/9, it is a 1x. The right side, 27 over 9, well, that is 3. So the left side is you're multiplying two things, get a 1. The right side is you are getting a 3 to replace the 27 over 9. So there you go. Multiplicative inverse and substitution property. Lastly, of course, the 1 disappeared. The 1x becomes just the x, and that would be multiplicative identity. And let's have a look at the whole thing again. First step, distributive, okay. Second step, substitution. So these are the 2 extra steps. And then POE, inverse, and substitution, then identity, and then POE followed by inverse and substitution, and then identity again. So you see, you're doing 3-step chunks. CBE is a 3-step chunk, and FGH is another 3-step chunk. Then you only have 2 extra steps that are not in the chunks that you need to figure out. There you go. That is example 2. Moving on. Example 3. First, you see from the original question to A, the parentheses are gone. And also the x and the -5 are separated. So that means you have distributed the 2, the name, distributive property of multiplication. And then let's try to think. You see step D, you are given 20 equals 2x plus 0. First thing, the 10 became the 20, the 2x stayed there, so the -2 times 5 becomes a 0. So at least that means the left side, you have to get a 10 in there. The right side, you also have to get a 10 to cancel out. But there are 2 separate steps. Well, technically, this step A, you didn't actually do the multiplication, so we are going to have to add an extra step. 10 equals 2x minus 10. Because you should know, you are getting a 0 right here, which means this step itself is the inverse. The previous step would have to be the POE. So if the C step is POE, then B has to be something else. So in fact, it is just replacing the 2 times 5 with a 10, and that is substitution property. Next, step C. As soon as you have that, you see the 10 become a 20, and the -10 becomes a 0. Well, we're adding 10 on both sides, so addition, POE. Next, as I was saying, the -10 and the positive 10 becomes a 0, and the 10 and the 10 becomes a 20. So you are canceling things out, 2 opposite numbers add together and get a 0. And also on the left side, you're just replacing 10 plus 10 with a 20. So there you go, additive, inverse, and substitution. Additive, inverse, and substitution. Next, even though the left side is not given, remember the 3-step chunk. 3-step chunk. These have to be the 3-step chunk. POE, inverse, and substitution. That tells you the next step has to be identity. So it's additive, identity. As soon as you know it's identity, well, identity, just get rid of the 0. So the 0 is gone. Next, if you keep solving the equation, it's time to get rid of that 2 now. Because you see step H, it is 10 equals x, which means in step F and step G, the 2 is gone. So now 20 equals 2x. If you're just solving that equation by yourself, you have to divide both sides by the 2. So there you go, division, POE. Division, POE. And that is the beginning of another 3-step chunk because you see you have a POE, which tells you the next step has to be inverse and substitution, and the following being identity. So there you go. 2 divided by 2, that gets you a 1, so it's 10 equals 1x. You got a 1, so that is going to be multiplicative inverse. Then 20 divided by 2, it is 10, so you're just replacing substitution. That's one way to think about it. Or again, right after POE, it typically follows by an inverse and substitution. Then from step G to step H, the 1 disappeared. That is the multiplicative identity. So that's a 3-step chunk. That's a completion of a 3-step chunk. POE, inverse, and substitution, and then identity. Lastly, 10 was on the left, now it went to the right side. X was on the right, now it came to the left side. So they switched. There you go, symmetric POE. That is step I. So you see, besides the two parts of the 3-step chunk, we only have these 3 extra steps that we need to recognize. That is example 3. Lastly, example 4. What would the first 2 steps be to solve and justify the equation? Well, first, 2x plus 3, well, you can't exactly combine them, but instead you see there's a 3 and a 7. So the first thing we are going to do is we're going to group the 3 and the 7 together so we can calculate that part first. And that, because we're grouping, you see 2 and a 3 were grouped together, now grouping differently. So it's going to be associative property since they're being added of addition. There you go. Next, we're going to calculate it. 3 plus 7 is 10. So it's going to be 2x plus 10. Well, that is my next step. I'm just replacing it. Equals 4x plus 2. Okay, because we're replacing the 3 plus 7 into a 10, that is substitution property. That is example 4. In next lesson, we will actually learn something more specific about exponents, but that will be all for now for 2.1b algebraic properties. Thank you.